Now it's time to start implementing the first three functions, which are mandatory for a functional ERC20 token. So let's create the first function. I'll copy paste the function signature from here, from the interface, to my contract. And inside the function, I write return supply. That's all. The total supply function returns the total number of tokens which is held in the supply variable. Then we implement the balance of function. I'll copy the function signature from the interface and paste it in my token contract. Okay, this is our function. The function must return the number of Cryptos tokens owned by this address. So return balances of token owner. For example, if I have an Ethereum address and I want to see how many tokens does that address have, I'll call the balance of, and as argument I'll pass that Ethereum address. And the last function I implement at this moment is the transfer function. Copy paste the function in my contract. This function will transfer from my account or from the account that calls the function this number of tokens to this address and will return a Boolean variable of true if the transfer was successful and false otherwise. This is a very important function. In fact, this is what makes the token transferable. Here we need a requirement. We must verify that the account that calls this function and sends tokens has that number of tokens in its balance. So if I want to send 100 Cryptos, I must have at least 100 Cryptos in my balance. So here I write require, and now the balance of the account that transfers tokens. So balances, in this variable all balances are saved of msg.sender. msg.sender being the account, in fact the address of the account that calls this function, that wants to transfer Cryptos. So this value should be greater than or equal to tokens, the number of transferred tokens. And there is a good idea to verify that tokens greater than 0. I don't allow the function to transfer 0 tokens. Let's take a look here on the Ethereum wiki page. And here it's a very good example. Let's assume that this token contract has only 2 token holders. This address with a balance of 100 and this address with a balance of 200. Then the balances of this address will be 100 and the balances of this address will be 200. Nothing special till now. The balance of function will return 100, respectively 200. Let's see how the transfer function works. So if the first address wants to transfer 10 tokens to another address, then the address that possesses the tokens will execute the transfer function, and the first argument will be the recipient address, the address that receives the token, and then the value that will be sent. After calling this function, balances of the first address will be 90 and balances of the second address will be 210. So, in fact, this function subtracts this unit from the balance of the first address and adds this unit to the balance of the second address. So, it's simple. Let's implement this functionality. So here I write balances of 2, so the recipient, plus equal to tokens. So I add to X balance the number of transferred tokens. If that address didn't have any token, there is no problem because X balance is 0. So I add this value to 0. And finally, that address will have only this number of tokens. And balances of msg.sender, so the address of the account that possesses tokens and transfers them, minus equal to tokens. If the function reaches this point, I return true. This function must also emit an event, so the transfer event. So here I'll create that event. So event transfer with uppercase T. I remind you that an event is written with an uppercase letter. So better I'll copy paste this line from the interface into my contract. This is the event, and here I emit the event. So transfer of msg.sender, this is from, to, this is the recipient, and the number of tokens. This will be a log that will be recorded on the blockchain when somebody transfers Cryptos tokens. And here we have to write emit. The transfer function is ready. We must also create or implement the contract constructor. In the constructor, I'll initialize the founder with msg.sender, so the founder or the owner of this contract will be the account that deploys the contract, and the supply with a number wanted by the founder. So here, let's create the constructor. Constructor, public, and now the supply can be an argument of the constructor or can be a hard-coded value. Let's say in this example, because it's simpler, to be a hard-coded value. So supply equals, let's say, 1 million. Here we have 1 million cryptos, and founder equals msg.sender. Okay, one question: who has cryptos at the beginning? So how could someone transfer cryptos to another account if that person that transfers crypto doesn't have them? So at the beginning, the founder will have all tokens, will have 1 million of cryptos, and he can transfer to other accounts. So here, balances of founder equals supply. And the constructor has been defined. We've developed a basic but functional ERC20 token. Our contract implements a real token. We can transfer tokens to other Ethereum address like any ERC20 token. In the next lecture, we'll test and deploy our ERC20 token on Ringby test network. See you there.